Okay, next up is data encryption, and there's a few things under this category that I want to cover. First off is full disk encryption, and this is basically referring to something known as data at rest encryption, and that encrypts the entire contents of a hard disk to prevent access without proper credentials. Okay, so data at rest doesn't necessarily have to pertain to the entire disk, but in this example, we're referring to full disk encryption. All right, so we're going to encrypt the entire contents of that hard disk to prevent access without proper credentials. So in other words, if someone were to steal a laptop, as an example, okay, you're sitting in your car, you run into the mall, you run into the office, whatever, somebody smashes the window, reaches in, grabs your laptop. Okay, all of a sudden it's gone. Well, if you have full disk encryption in place, the data on that drive is basically useless to them. Okay, so they can take the disk, they can pull it out of that laptop, put it into somewhere else, unless they have the credentials to either log in and decrypt on the fly, or they have some type of brute force attack where they could really crack those encryption keys, which isn't likely to happen. Okay, that data is, for the most part, safe. Okay, next up, talking with data encryption for databases, we have two types that I want to cover briefly, and that is TDE, or transparent data encryption, and cell-level encryption. Okay, the distinction between the two is the fact that transparent data encryption is encryption at rest, and it also encrypts the entire database. Now, that may or may not be most applicable or the most appropriate for a specific database. So if the entire database needs encryption, then fine. If we only have certain sections of the database, let's say, for instance, it's a large database that contains a lot of generic information that multiple users need access to, but then we have specific columns or specific cells that contain PII, or personally identifiable information, perhaps a social security number, or perhaps credit card numbers. Well, those we want to restrict access to. And we do that with cell-level encryption. Additionally, cell-level encryption also encrypts data in transit. So it doesn't actually decrypt until the application using it decrypts. All right, so there's a few things that have to be in place to be able to use cell-level encryption, but just understand the differentiation between the two. Transparent data encryption encrypts the entire database, encryption at rest, but it does not encrypt in transit. Conversely, cell-level is very specific, it's granular, and it also does in fact encrypt data in transit. Okay, next up is data encryption for individual files. Now, as you might guess, for individual files or folders, we can encrypt the data, obviously to protect sensitive data, and depending upon the operating system, files will be unencrypted if copied to another location. All right, so just something to keep in mind. Just because we copy something, right, and have it stored in a file or a folder on a specific partition within our computer, if we copy that file or folder somewhere else, again, depending upon the operating system, it may decrypt on the fly, and it may land unencrypted. All right, so that's just something to keep in mind when you're working with file encrypting technologies, whether it's BitLocker from Microsoft, or there's some other ones like TrueCrypt, which is actually defunct now, but it's still out in use, or Symantec's drive encryption. There are a number of third-party drive encryption technologies out there. Just understand the ramifications of moving and copying files from one location to another. Okay, next, data encryption for removable media. You may or may not have policies within your company to require removable media, i.e. thumb drives and things along those lines, to be encrypted to ensure sensitive data doesn't leak from the company. All right, so you can put in place policies that require, if someone puts a thumb drive into their laptop or their desktop, it automatically becomes encrypted. All right, so that kind of ensures that if someone were to copy some data to a thumb drive, maybe to take home or to utilize that data on the go, if that thumb drive falls out of their pocket or they leave it somewhere, rental car, I mean, you name it, could be anywhere, obviously, right? That data doesn't get picked up inadvertently or by someone who just happens to walk by and see it, pick it up and say, hey, wonder what's on this, put it in their own laptop, and then all of a sudden they have access to that sensitive data. So depending upon the policies within your company, again, we can require that encryption take place. And then how about data encryption for mobile devices? Again, mobile devices can encrypt data locally, and some phones, some operating systems are more secure than others. There's always the the almost religious, passionate argument between Android and iOS users, one saying one is better than the other. Okay, I'll leave that up to you and your company to decide which is most applicable. But just understand that mobile devices can encrypt data locally, and you can enforce this via policy as well. You can turn on encryption, you can turn on certain security features, and you can mandate that users of cell phones, mobile devices, and so forth on a network access corporate resources via VPN or SSL. Okay, so there can be encryption at the local level, And there can also be encryption while data is in transit or data in use, so to speak, right? So again, just depends upon the policies within your company, and understand that each of these have ramifications whether you choose to or not to implement these policies.